Hello, Algebra 2. This is assignment A13. This is the last one, multiplying radicals. So, minus 2 square roots of 15 times 3 square roots of 6. Remember, it's just multiplication. Commutative property is always helpful. I'm going to reorder this as minus 2 times 3. And I'm going to factor these while I do this, or that prime factorization. 15 is 3 times 5, and 6 is 2 times 3. Remember that if you have a product of square roots, you can make it a square root of a product. Minus 6 times, and watch how I write this. I'm going to write, I like to go from least to greatest, so I'm going to write 2 times 3 squared times 5. Okay? At this point we can pull out this perfect square, then I'm going to rewrite it one more time. I'm going to write it as two more times. Minus 6 times 3 squared times 2 times 5. And I'm going to redo it as minus 6 times the square root of 3 squared times the square root of 10. Okay? The square root of 3 squared is just 3, so we have minus 6 times 3 times the square root of 10, or minus 18 square roots of 10. Okay? You know that I like to write out all the steps that I can think of. I don't like to skip steps just because I don't want to confuse you. If you don't need to write steps, don't write steps. I think you'll find that pretty soon you'll be able to skip steps pretty quickly and do all kinds of fancy hand waving. Okay. 7. Woo-wee. 7 times 24. Let's do the prime factorization of 24. It is 2 cubed times 3, right? 2 times 2 times 2 is 8. 8 times 3. And this is 2 times 3, so I'm going to write the square root of 7 times 2 to the 4th, 3 squared. 2 to the 4th times 3 squared. You might know that this is asking you for the square root of 16, right? But, however, 7 times the square root of 2 squared times 3 squared. So the reason I did that is because the square root of something squared is just that something. So 7 times 2 squared times 3, 21 times 4 is 84. So 7 square roots 24 times the square root of 6 is equal to 84. Who would have known? Let's do this one, shall we? Let's just put everything under there right away. And let's say we have 3 times 7 is 21, but we have another 7 there. And how many x squareds do we have? X cubed times x squared is x to the 5th. Hi, how are you?
Good.
What are you up to? And we're talking to the Algebra 2 class. You can come wave to them. They're fun.
Hi, Algebra 2. I am here to photocopy some textbooks for some students that can't handle the computer anymore. So, good job, guys. Hanging in there with that technology.
They're doing really well.
I've only heard great things about you guys.
I talk about you almost all the time.
Too much.
Ah! Okay, 3 times 7 squared times x to the 5th is what we have there totally. Remember how we simplified these square roots last week? I'm going to rewrite this as 3 times 7 squared times x to the 4th times x. So if we have an even root, if we're taking an even root like a square root and the exponent is odd, we're just going to take one of those off because we can take the square root of an even. We can take the square root of an even exponent. So I'm going to rewrite it as the square root of 3 times 7 squared times x squared times x. So I can pull out all the perfect squares. What is the square root of 7 squared? 7. What is the square root of x squared? X squared. You guys are good at this. 7x squared times, what is left? We have a 3 and an x in there. Okay, so there you go. 7x squared times the square root of 3x. 2 more. Oh boy. Foiling. First, 7 times 3, 21. Outer, 7 times 2 square roots of 3 is 14 square roots of 3. 3 times minus square roots of 3 is minus 3 square roots of 3. And we have minus square roots of 3 times 2 square roots of 3 is minus 2 square roots of 3 times square roots of 3. I'm going to write it like that just so you can think about it. 21, 14, take away 3 is 11, so we have 11 square roots of 3. And have you thought about this one? Yeah, that's right. That is minus 2 square roots of 3 squared. Or minus 6. 21 minus 6 is 15, so we have 15 plus 11 square roots of 3. And finally, one more. You remember, look at this guy. 3 square roots of 2 plus 5 and 3 square roots of 2 minus 5. Do you remember the word for things like this? I would say A plus B is the conjugate of A minus B. Remember we saw conjugates when we dealt with complex numbers, and we found that if we took the conjugate of a complex number and multiplied it by the complex number, we would get a real number. So if we have this is a radical expression because it's got an irrational number in that, but if we can multiply it by its conjugate, we will make this irrational number rational. So let's try that, shall we? 3 square roots of 2 times 3 square roots of 2. That's 3 squared times the square root of 2 squared. I'm skipping steps now. I hope you're okay with that. This is, you could figure it out. Outer, minus 5 times the 3 square roots of 2 is minus 15 square roots of 2 plus 15 square roots of 2, and plus 5 times a minus 5 is minus 25. So you can see that the outer and the inners cancel each other out just like they did in the complex numbers where our imaginary parts cancel each other out and disappear. So 3 squared times the square root of 2 squared is 9 times 2, 18, minus 25, minus 7. Okay? So if you have a irrational number and you want to make it rational, multiply it by its conjugate. That simple. So this is the last assignment for you. Please make sure that you do it. Okay? Next year, you guys will pick up right here. You will pick up right with the radical expressions, so you can completely jump into your pre-calculus class ready to go. You're only 2 or 3 weeks behind where we probably would be with this. Okay, so you're not left in that bad of a position. I love you. We'll talk to you later.